So I promised you naming of alkynes. I know it's a little later on in the what you need to know list, but that's okay. We'll talk about them anyway. Alkynes have triple bonds. Okay, here's a triple bond. We fill in all the hydrogens. No, you don't need any here. You don't need any here. Here's 1, 2, and then 1, 2, 3. So you want to number it so that the triple bond has the lowest possible number. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4. So number it left to right. 1, 2, 3, 4, 5. The suffix will be YNE, and this would be at carbon 2. You have 5 carbons, so that's a pent. So that is 2-pent ine. Okay. Sometimes you get these molecules that have double bonds and triple bonds in them. So let's say you have something like this. Make your life interesting here. Let's say here's a double bond, and let's say here's a triple bond. Let's pretend all the hydrogens are there. This is just a skeletal structure. So you got to tell someone that you have a double and a triple, and you have to tell them where they are. Can you see that the double over here would be at a lower number than the triple? So let's go with this 1, 2, 3, 4, 5, 6, 7. It's got 7 carbons, so it's a hept. But you break up the name and you call it an ene-ine. So it's a hept-ene-ine. This is where students sort of tune out. Don't tune out. It's not that bad, honestly. You got to tell me where the ene is. So you're going to write down 1-heptene. Okay, 1-heptene. Now, if it was just a heptene, you would end it with an E and you'd be all done. But you drop that E because now you need to put in the word ine or the suffix ine. So 1-heptene dash 4-ine. That's how you name it if you have an ene and an ine in the same molecule. Sometimes you have 2 double bonds or 2 triple bonds. So let's just do an example of 2 double bonds. So let's just do this, line drawing. Let's have a double bond here and maybe a double bond over here. All right, so let's count the number of carbons. 1, 2, 3, 4, 5, 6, 7, 8. So if it was just 1 double bond, it would be an octene, but because we have 2 double bonds, we're going to call it an octdiene. Okay? So suffix is diene now, and we're going to put oct because it's 8, but we have to tell everybody where the double bonds are. Lowest possible numbers, we're going to write right to left, 1, 2, 3, 4, 5, 6, 7, 8, and this would be 2, 5 dash octdiene. All right, so there's some nomenclature that you need to know. If you have a double triple, this is what you would do if you have 2 doubles. And if you had 3 double bonds, it would be a triene. Unlikely you'll have more than that. All right. I mentioned some common names back in the common names with the alkanes. Let's do common names of these guys. Ethene is ethylene. Ethyne is acetylene. So let's do this again. Ethene is ethylene. So this is IUPAC, and this is common. Ethyne, which is triple bond, is acetylene. And we said propene is propylene. Okay, so these are the common names you need to know out of this chapter for alkenes and alkynes. All right, we're ready to move on to isomers. Isomers super important. There are different types of isomers. If you're going to just move the double bond or move the triple bond, you move the position of the double or triple bond, you've created an isomer. So let's say I've got this molecule here and then this molecule here. So butene and butene. Notice they look very similar except the location of the double bond. This over here would be 1-butene, and this over here would be 2-butene. So these are isomers just because we moved the position of the double bond. They are same molecular formula, different structure, different name. The structure differs because of the position of the double bond. Just remember, isomers are always going to have different names. They have to have the same molecular formula, but completely different names. You could do the same thing with a triple bond. If you put the triple bond here, it would be 1-butyne. If you put it over here, it would be 2-butyne. Now, double bonds create these interesting isomers called the Sis Trans Isomers. Remember how we saw those when we were talking about cycloalkanes? Well, you can get Sis Trans Isomers, Sis Trans geometric isomers with alkenes. Your alkene is rigid. Let me just show you here. Rigid. This is rigid around the double bond. You can't rotate it. So if you have this ethene, and let's say you have a bromo over here and a bromo over here, the bromines are stuck in this position. They are opposite each other. Do you guys remember what opposite was with the cis trans? Opposite sides of the double bond is the same as opposite sides of the ring, trans. If they're on the same side, they would be cis. So this over here would be a trans. If you break it and move it on the same side, this would be cis. Why do we have cis trans isomers in an alkene? Because there is no free rotation, and we can see above the double bond, below the double bond. So it's geometrically makes it a little different, so you can create isomers. All right, so drawing this out, and the geometry around the carbons of a double bond is trigonal planar. And if you remember, the angles in trigonal planar is 120 degrees. For the tetrahedral, remember, with the alkanes was 109.5. With the alkenes, it's trigonal planar, 120 degrees. Notice that the two bromines are on opposite sides of the double bond. So when you name this, you know it's an ethene, you know that the bromos are on carbons 1 and 2, but you got to put the word trans at the beginning because this indicates the location opposite each other on the double bond. So this would be trans dash 1, 2 dibromo ethene. Okay. So that was that first one. The second one over here, they're on the same side of the double bond, and so that's when we use the term cis. So let's draw that out. Also 120 degrees. This would be cis 1, 2 dibromo ethene. All right, one thing you should know about cis trans is that you can only have cis trans in an alkene if the two things attached to the carbon are different. Like if you had a bromine here and a bromine here, identical, can't have cis trans. You can only have it if they are different. Like you could have a methyl and an ethyl, a bromine and a hydrogen, a chlorine and a hydrogen, stuff like that. So let me show you a scenario. If you have this, or you have something like this. All right, so this is butene and this is butene. Can you guys see that? Longest parent chain, butene, butene. Remember, longest parent chain, butene and butene. This is 1-butene. This is 2-butene. But notice over here, you have 2 hydrogens attached to this carbon, and so you're not allowed to do cis trans here. They're identical. But because here you've got a methyl and a hydrogen, this can be cis trans. Since the 2 hydrogens are on opposite sides of the double bond, guess what it is? It's not on the same, it's opposite, it's trans. So trans, 2-butene, no cis trans, and there's no cis trans in alkynes. Okay, good. We are ready to move on to physical and chemical properties. We'll do that in the next video.